Hello, everybody. How are you today? I'm hoping that you are having a blessed day today. Um, we're going to be talking about truth tables for this video. If you may have never heard, if you may have not heard of truth tables before, it's just a concept that resides in formal logic, in basic formal logic. You may have already heard it from school, but today I'm going to try to make it more in depth and comprehensible for you all. So let's start with the first concept that we need to know about truth tables, which is negation. Okay, but first, before we get to negation and conjunction and other stuff like that, let's first try to define what is what is an argument. Okay, excuse my illegible writing. So what is an argument? An argument is basically just a premise. It's basically just a premise, an order in which you have to use reasoning and evidence in order to prove it. An argument can be a claim. An argument is synonymous to a claim from my own understanding. Okay? So an argument is a claim. But what do we need to know this for? What exactly is the purpose of knowing this? Well, the purpose of knowing this is so that you can understand what formal logic is founded on and what is the base that formal logic really builds itself up on. An argument is the very first principle building block that you need to know in order to understand formal logic. So let's say you have an argument, okay? Let's say you have a claim. Let's let's opt for the Aristotelian syllogism, which goes like, if you may have already heard of this before, but I'll just type it out here. All men are mortal. Socrates is a man. Therefore, Socrates is mortal. Here you can see right here, this is a perfect example of a claim that has reasoning behind it, and reasoning and evidence behind it. We can just analyze the first statement that is inside this Aristotelian syllogism. By the way, this whole three lines right here, you call that a syllogism. A syllogism. Okay. But first, let's define what a syllogism even is. A syllogism is a structured deductive argument where a conclusion is drawn directly from two assumed or proven premises. Okay? So basically, as I said earlier, arguments are built upon premises, these claims, and those claims are supposed to linearly linearly nudge you into a valid conclusion. And this is one of the most famous syllogisms ever. So let's analyze the first statement here. All men are mortal. Okay? And that's true. Mm, Um, that's true. That is the first claim. Okay? That is the first premise. First premise. By the way, when I say premise, I'm still referring to claims. They're practically synonymous to each other. So we have the first premise, which is all men are mortal, and the second premise, which is Socrates is a man, which is also true. And this is going to be the conclusion that comes from those two premises. Now, would you say that this conclusion right here is valid from these two premises that were stated uh, preceding this conclusion? Do you think that this conclusion, by that extent, is valid? If you answered yes, then you're correct. You would be correct because these two statements directly, okay, these two statements right here, they directly support this conclusion. All men are mortal, and Socrates is a man. Therefore, Socrates is mortal. Okay, and that's just one simple example on what a uh, proper argument or what a proper argument is by using logic, by using formal logic. Okay, so now that we've tackled that, let's go on to truth tables. Let's go on to the main discussion of this video, which are truth tables. Okay, so what are truth tables? They're basically just tables that have certain statements in them or premises that have certain premises in them that can either be true or false. Okay, depending on which statement is true or false, the conclusion can either be true or false following those statements. Okay, so let's first start with negation. And let, but first let's try to draw out the truth table first. I'm just going to add titles to these columns. Okay, so let's say this is statement one. Okay, this statement one. Statement one. This will be statement two. Let's first start with negation. Let's first start with negation. Okay. In negation, in truth tables, regarding truth tables, when it comes to negation, you're basically just saying the opposite of what you what the statement is. Okay, the opposite statement of what this the opposite statement over the of what the current statement is. So let's say um, let's extract one of the premises that are inside that syllogism that I just showed you earlier. Let's say the statement is all men are mortal. Therefore, the negation for this, and there is actually a there's actually signs for this. So, but we'll get to the signs later. Okay. So the negation of this would be all men are not mortal. Okay. Seems pretty simple, right? If statement one says that all men are mortal, then the negation of that would obviously be all men are not mortal. Okay? Or all men are immortal. Okay? So let's go to the signs. Because truth tables are inherently very, very short, and they just consist of letters. Okay? These consist of letters and symbols. So there are various ways to depict depict the negation sign, the negation symbol. As you can see right here, there is this that what looks like a horizontally horizontally flipped L right here. There can also be this squiggly line, and um, this line on top of the statement. Yeah. Okay. So I'm going to opt for this squiggly line because it's a bit exhaustive to copy and paste this negation symbol. But this is the main negation symbol that you should take note of, because that is what that is what that is what teachers and professors usually use in order to demonstrate negations. Okay. So this is statement one. P will stand for statement one, and Q will stand for statement two. So we have statement one over here, which says that all men are mortal. Okay? All men are mortal. It's true. Then the negation of that, yeah, then the negation of that will be false. Okay? Okay? So let's say you have another um, let's say you have another statement. Okay? Socrates is a man. The negation of that would be Socrates is not a man. Okay? I think from this point onward, you could really just foresee where I'm going with this. It's very simple to understand. Negation is self-explanatory. You just have to negate whatever statement you have, and that's it. That's basically it. So now that we're done with negation, let's go on to the more juicy stuff. Um, we have statement one over here. Okay. Now I'm going to add another title for a column, statement two, and hold on, just check. Let's say that you have two statements. Okay. Now that we've already covered what negation is, let's go on to what we call conjunction. Conjunction sign, if it helps for you to understand it more, Oh, sorry about that. Let's just write out. Let's just type it out as an A, but the symbol, the conjunction sign, is sort of like an A. Okay, it's sort of like an A, but without the line, uh, without the intersecting line. Okay, so let's go back. Okay, this will be the symbol for the conjunctions. The conjunction is basically just you saying "and," the word "and," A-N-D. So if you have one statement right here, let's say, um, I will buy you a PS5 and I will buy you an Xbox. Okay? There are two statements right here. These two statements will be locked in together with the word "and," with conjunction. So let's say you have let's say you have statement one, I will buy you a PS5. The statement two, which is I will buy you an Xbox. Okay. Let's say that I didn't buy you. Wait. Let's start with truths first. Okay. Let's say that I bought you a PS5 and I bought you an Xbox. Then the first statement will be true as well as the second one. So the truth value of the conjunction will be true because I bought you both of them. Okay? Because I bought you both of them, then that means that means it's true. Okay? Let's say that I didn't buy you a PS5. Okay? Let's say that I didn't buy you a PS5. Hold on, let me just. Okay? Let's say that I didn't buy you a PS5. Then this first statement will be false. The second statement, let's say that I did buy you a PS5. Wait, no. I'm sorry about that. Let's say that I didn't buy you a PS5, but I bought you an Xbox. Then the first statement would be false because I didn't buy you a PS5, but I did buy you an Xbox. So that means the second statement will be true. And the answer to the conjunction, which which do you think will be answer? It's either true or false. The answer would be false. Okay? And why false? Because there are two statements right here. Okay? And they're basically interlocked with each other. If I bought you a PS5 and I didn't buy you an Xbox, and if I didn't buy you a PS5 or I bought you an Xbox, um, the statement itself would be completely false because conjunction relies on two statements being true. Okay, so naturally, if I did buy you a PS5 and I didn't buy you an Xbox, then the whole statement would still be false. Okay? Now let's say I didn't buy you a PS5 and I didn't buy you an Xbox neither. So I basically lied to you, right? I basically lied to you and or I'm a cheapskate, or maybe I'm a cheapskate. Okay, so then both of the statements will be false. Then the whole statement, then the whole conjunction will be false as well. Okay, that will be the concept of conjunction. Now we can circle back and go to now we can proceed to disjunction. Okay. Okay. So let's say let's switch out the statements. Okay. Okay. So statement one, I will play basketball. And statement two is I will play soccer. So disjunction, it looks like a V. The symbol of disjunction would be a V. And what it basically entails or describes is that either of the statements can be true. Okay? But they can't be true at the same time. I believe that is what disjunction is. Okay? We can just search up right here. Oh, I'm sorry. That was actually my fault. Um, that previous statement that I said, it's false. I the disjunction can also have two statements that are true and still be true. Okay, so let's start here with this example. Let's say that I said I will play basketball or I will play soccer. Okay, so if I play basketball and then I play soccer. Okay. Oh, hold on. Let me just change up the statements so we could be more accurate with this because uh, my example will be a little bit confusing from that point on. So okay. Let's just say that uh, John will buy you a Rolex. Okay. John is pretty rich. So let's go on to the second statement. Let's say that John, okay, okay. So let's go back. Um, let's say that the second statement is John will buy you a Casio. Okay, a Casio watch. For you, those of you who don't know, that's a brand. It's a brand of watches. You can just search that up. Okay, so now that we have these two statements here, we have the first statement. The first statement. Let's say that the first statement, um, John will buy you a Rolex, was true, and John did buy you a Rolex, and John also bought you a Casio. Then that means that both of these statements will be true. Okay. Knowing that these two are true, then the disjunction will be true as well. Okay. Now let's say John bought you. No. Let me just. Okay. Let me just circle back. Okay. So let's say that John didn't buy you a Rolex, but John did buy you a Casio watch. What will be the answer here? The answer will be true still. It will still be true because John still bought you a Casio. Okay? See right here? John still bought you a Casio. So the statement, because the disjunctions is basically just or, just the word or, if that is a good hook for you to learn it more, for you to learn it easier, disjunction is basically the word or. Okay? So John will buy you a Rolex or a Casio, and he did buy you a Casio. So that means that the disjunction will be true. Okay? And this will be the same for this. If John bought you a Rolex, but he didn't buy you a Casio, he still bought you a Rolex. So that means the answer will be true. Now, let's go to the last classification of statements. If John bought you a I'm sorry. If John didn't buy you a Rolex, nor did he bought you a Casio, then the whole disjunction will be false. Okay? Seems pretty simple enough. Now that we've already tackled negation, conjunction, disjunction, let's talk about now let's tackle the conditional statements. Okay? Let's say that you have this example. Okay? Conditional statements, by the way, are depicted by arrow signs, right arrow signs right here. That's going to be the symbol. And the conditional statements, basically, you could just say if and then. Like conditional statements are if and then statements. Okay? If then statements. You know how in computers, whenever you're creating code, there's always going to be an if and then statement. The same will be, well, the same will apply here in formal logic. So here's the statement that we're going to be starting with. Statement one: if I'm on Reddit arguing 24/7, then I'm unemployed. Okay, so let's say that you are on Reddit and you are arguing with random online strangers 24/7, and you are unemployed. Both statements are true. Then that means the conditional statement will be true as well. Okay? Now let's say you're not on Reddit arguing 24/7, but you are unemployed. The conditional statements say that it will only be true if the consequent action or the consequent in conditional statements, this will be referred to as the consequent, and the preceding statement, the statement one, will be referred to as the antecedent. Okay, this is the antecedent, this will be the consequent. Let's say that you don't go on Reddit arguing 24/7 with online strangers, but you are unemployed. Okay, then this statement will still be true. Okay, because because the consequent is true, so it'll still be true. Okay, so let's say you are on Reddit arguing 24/7, but you aren't employed. Okay, then this whole statement will be false. And if both statements aren't true, then it'll still be false. Let's see if I'm correct on that. Oh, let me see that. T T T. Got got T T T. Okay. Got T F F T F F. Got F T. Yeah, F T. True. F T. True. Yeah, F F is still true. So this is the only thing that we should that I got wrong. It's actually going to be a true. Okay. So now let's go on to biconditional statements. Okay. Okay. Now we're going to be tackling the very last part of truth tables, which are biconditional statements. So let's say I removed I already removed the column wherein it says statement two, but this is very obviously statement two. It is divisible by two. So let's let's just keep that in mind. Biconditional statements are basically depicted as if and only if, and their symbol is these two arrows right here. Okay. So statement one will be a number is even if and only if, biconditional statement, if and only if it is divisible by two. Okay. So let's say that the number is even. It is divisible by two. Both of the statements are true. So therefore, the coinciding biconditional statement will be true. So now let's say a number is even, but it's not divisible by two. Okay? Then the biconditional statement will be false. Let's say that that a number isn't even, but it is divisible by two. It will still be false because biconditional statements rely on both of the truth values either being both true or being both false. And the last would be number isn't even and it isn't divisible by two. This will be true. A number isn't even if and only if it isn't if it is divisible by two. Okay. So this will be true because both the statements agree with each other. Okay. And that will be all for argument, syllogisms, and truth tables.